which values of x, not where this is absolutely convergent, but where it is conditionally convergent. And that one change is going to add a couple steps to the end of the question. So first up, we want to, sorry, I got other people's work up here. We want to first start off by thinking of this as absolute convergence and doing the ratio test. So I'm going to do the limit as n goes to infinity of the absolute value of n plus 1. And I'm going to go ahead and just split that up. X to the n plus 1 is like x to the n times x to the first. Same down here. 4 to the n plus 1 would be 4 to the n times 4 to the first. Okay, so all of that would be a sub n plus 1. And then if I divide it by a sub n, or multiply by the reciprocal, well, if I want this to be absolutely convergent, I want to make sure that this is less than 1. That's what the ratio test tells me. Now, since I've already split apart stuff with my exponents, I can get quite a bit of stuff to cancel out. X to the n's cancel. We've got a 4 to the n that would cancel. And then we've got a bunch of other stuff. Now, again, I know you guys are just coming back from break, so this is a little rustier. But one thing I suggested, especially in the ratio test, when you've got so much stuff going on, make one step where you just put like all of your n stuff up front, n plus 1 times an n squared plus 1, and then put all your other stuff like x's a little bit out to the side, and you'll see why I'm going to do that. Got an n and an n squared. Okay, and the reason I suggest doing that is because the limit is only as n goes to infinity. The limit has nothing to do with x values. So if you put all the n stuff up front, you can just focus on this limit, and 9 times out of 10, the limit's going to go to 1, because that makes the rest of the question work out kind of interesting. So I don't want to multiply this stuff together, but if I did, I can see the numerator would be degree 3, and this n distributed to what this would be n squared. This numerator has degree 3, so if the degrees are equal, we would need to put leading coefficient over leading coefficient. So like I said, a lot of times this just goes to 1, but you actually need to test to make sure that the degrees are the same before you do leading coefficient over leading coefficient. So since all of that just goes to 1, what I really care about is when is the absolute value of x over 4 less than 1, which is the same thing as saying when is x minus 4 less than 1 or greater than negative 1. And then you can multiply everything by 4. And what I have just done is I have figured out where it converges absolutely. But that wasn't the question. It didn't want us to find where it converges absolutely. You did other questions where you practiced that. It wanted us to figure out where it converges conditionally. So D is pretty close, but not quite what they're asking for. So the last thing is, and again, they really should have put this in the notes, but it converges absolutely when x is bigger than negative 4 and less than 4. But it could be conditionally converging at x equals negative 4 or x equals positive 4. These two times are not absolute, otherwise they would have the equal to sign already, but they might still be conditional. So for you to test, I'll test x equals 4 first. I can go up to the original question, rewrite it, but instead of saying x, I'm going to say 4. And then you can see you've got a 4 over n and a 4 over n. So those kind of cancel out, and then you're left with n over n squared plus 1. So you could test this on its own. So I don't know. Honestly, the only way I think I could do it quickly would probably be integral test, would be my guess. Basically, I'm just plugging in 4 for x, and then I'm working it as its own question. So this would be like, maybe I shouldn't have picked this one. I was trying to pick out the one that wouldn't work, so then we could go back and see the difference, but I just added a bunch of extra work for myself. D squared plus 1, Tn, natural log, has a value. Let's do b squared plus 1 minus natural log, absolute value of 2 half times all this. Okay, so I'm going through that part pretty quickly, but eventually when you do the limit part here, you're going to get infinity minus a number. So this diverges. So numbers smaller than 4 converged absolutely, but when I tried to plug in x equals 4 and test it, I ended up getting diverge. So if x equals 4 diverges, it's not converging conditionally. So you know it's not that. And then the reason b equals negative 4 works out great. Erase some of this. Same idea. If you rewrite the original question, but instead of putting x, you put negative 4, so I'm testing the other side of that. I get a negative 4 to the n divided by 4 to the n, which I could rewrite as negative 1 to the n. Okay, so the work I did over there was not for nothing, because this is the alternating version of it. This is an alternating series. So to know if this converges, you need to think about a sub n, and does the limit of that go to 0? Yes. And do the terms of this get closer and closer to 0? So the first term would be 1/2, and then 2/5, and then 3/10. So this does converge using the alternating series test. So all of that to say this is when it converged absolutely, which a lot of times that's all that you're going to be asked. But if you need to know when it converges conditionally, you need to test these two endpoints. X equals 4. I plugged in 4 for x, worked it as its own question over here in green, but it diverged. So that did not converge conditionally. And then I tried x equals negative 4, which ended up working. I plugged negative 4 in for x, worked it as its own question, and it was in converging alternating series. So even though negative 4 was not converging absolutely, because there's no equal to sign on that, it still converged conditionally because I tested it manually. So are you okay with how I plugged in negative 4 into the original problem and just tested it? Okay. Yeah.